Hello and welcome to the tutorial on how to write a polynomial of a given degree with given zeros. Given in the problem is that there are zeros of 2 and negative 3 plus I, as well as the fact that it needs to be degree 3. The first zero is given of 2. The second zero of negative 3 plus I is also given. The third zero of negative 3 minus I is achieved by knowing the conjugate zeros theorem, which states that if negative, in this case, if negative 3 plus I is a 0, negative 3 minus I is a 0. And we also need to remember that if x equals c is a 0, then x minus c is a factor. So 2 being a 0 means that x minus 2 is a factor. And in the same vein, x minus negative 3 plus I is a factor, as well as x minus the quantity of negative 3 minus I is also a factor. Now you could do a variety of things here to multiply these last two parentheses together. However, I'm going to use FOIL in a slightly different way here. We are going to take x times x. That's no big surprise. It's just simply x squared. And then we're going to take x times this here as our outer term. Remember, FOIL is F-O-I-L. The O stands for outer. So I have minus x times negative 3 minus I. Next, the inner part, which is also minus x, but this time it's times negative 3 plus I. And last but not least, we're going to multiply the last terms. Negative times negative is a positive, so I'm going to simply write negative 3 minus I times negative 3 plus I. And now we just have to clean this up. Do not forget that we have an x minus 2 here. So this is x squared plus 3x plus ix plus 3x minus ix. And then here you're using another FOIL here. So this is plus 9. And because they're conjugates, the O and the I, the outers and the inners, should cancel, leaving us with just the last term to multiply, or minus I squared. Clean this up. X squared plus 3x plus 3x. That's 6x. Ix minus ix is gone. And then you'll recall that I squared is negative 1. So you have 9 minus negative 1, or 9 plus 1, or simply 10. And then the last part of this problem is to simply multiply x minus 2 times the quantity x squared plus 6x plus 10. Multiplying through by x, we get x cubed plus 6x squared plus 10x. Multiply through by negative 2. We have negative 2x squared minus 12x minus 20. And clean it up so that our final polynomial is x squared plus 4x squared minus 2x minus 20. And that is our final polynomial. So here's a new problem. Again, we're looking for a polynomial of degree 3, and the given zeros are 4 and 2 minus I. Again, using the conjugate zeros theorem, since 2 minus I is a 0, 2 plus I must also be a 0. And like before, if those are the zeros, then x minus 4 must be a factor. X minus 2 minus I must be a factor. And x minus 2 plus I is a factor. And once again, we are going to FOIL items, starting with the conjugates. First times first is x squared. Then the outers, giving us minus x times 2 plus I. Then the inners, giving us minus x times 2 minus I. And then last times last, negative times the negative is plus what? 2 minus I times 2 plus I. Simplify. Should always have equal signs. X squared minus 2x plus ix. That actually should be a minus ix. Minus 2x plus ix. And again, using FOIL here. This is plus 4. The outers and inners cancel, and we have minus I squared. Time to clean it up. This is x squared minus 4x, negative 2x, negative 2x. The ix's go away. I squared is negative 1. 4 minus negative 1 is 4 plus 1, or 5. And once again, we have gotten rid of the i's, and we now multiply through. X times each one of these is x cubed minus 4x squared plus 5x. Now negative 4 times each one of these. Negative 4x squared plus 16x minus 20. Clean that up, and we have x cubed minus 8x squared plus 21x minus 20. And there is your polynomial of degree 3 real coefficients. Notice there's no i's in there, even though we started with i's.